This is Chemistry 2, a review of double replacement reactions. So we're going to just briefly review double replacement reactions today. This is going to help us with our new unit for after Christmas break. So if you remember, if we have two compounds, we'll call them AB and XY. So we start with two compounds and we end with two compounds, and they swap places. So the ions within here swap partners basically, and we end up with XB and AY. So we end up with two new compounds. But one of three conditions must be met. And either H2O, a gas like CO2, H2S, SO2, or a precipitate. So we have to have one of these must be a product for a reaction to take place. So for this, if we form water, then we have a double replacement reaction. If we form one of these gases, we have a double replacement reaction. If we form a precipitate, one of the two products is a precipitate, we have a reaction. If these are not met, we have no reaction. It just sits there. So in order to figure out whether we have a precipitate, we have to look at a table of solubilities. And you should have this in your packet. I also sent this in email. So here we have a solubility table. And this solubility table tells us whether or not something is a precipitate or not. So if we look at this, we would take the name of the compound. Here is the cation, here is the anions, and some of them are polyatomics. So with these, if we look, aluminum acetate, we have an S. An S means it's soluble in water. Anything other than S, we are going to count as a precipitate. So if we have a line, if we have an A, a little a, an I, a P, any of those means that we have a precipitate form. So aluminum hydroxide is a precipitate. Aluminum oxide is, aluminum silicate, aluminum sulfide. So we have to make sure that we do not have soluble compounds, or if we have insoluble precipitates. So we would consult that. So let's look at an example. Let's say that we have KOH plus aluminum nitrate. And we're asked to predict what this is going to be. So again, we're going to take our two positive ions and we're going to swap places. But we have to worry about charges with these. So K is +1, Al is +3. So look at your periodic table or polyatomic ion charts. Those are in your note packets from the first unit we did on a review of chemistry. So K and NO3 are going to go together, and aluminum and hydroxide are going to go together. So K is +1, NO3 is -1, so those cancel out, so it's KNO3. Aluminum is +3, hydroxide is -1, so when we write the charge of this, we have to have 3 hydroxides for each aluminum to balance out the charges. So now we have to look at these two things and see if we have a precipitate. So if we go to our table of solubilities and look at potassium, we can see the potassium, any potassium compound is soluble. So we're going to put a little AQ after that one to mean soluble. So AQ means aqueous or soluble in water. Aluminum hydroxide has an A after it. So that means that it is a precipitate. So we're going to indicate that by putting a solid there. That means solid. I know that in a chart, S means soluble, but here it means solid. So solid precipitate. So PPT is an abbreviation for precipitate. The last thing we have to do is balance this chemical equation because we know that a reaction occurred. If aluminum hydroxide was AQ also, we would put no reaction or NR. So we have 1K, 1K, 3 OHs on this side, 1 OH on this side. So I'm going to put a 3 here and put a 3 there. So now it is balanced. Let's look at one more example. Let's say that I had ammonium sulfide and HCl. So for this one, ammonium and hydrogen are going to swap places. So we're going to have H and S. H is +1, S is -2. So we're going to have H2S plus NH4 is +1 and Cl is -1. Now, hydrogen sulfide, this we just have to know that's one of our gases up here. And all ammonium compounds, for the most part, are soluble. So now all we have to do is balance this by putting a 2 here and a 2 there. But you just have to recognize that there are 3 gases that are possible. So go ahead and try the problems that I sent you on the worksheet.